In our first example, we are going to see a derivative of a function that is a composite of three functions. We're going to do it in two ways. We will start by just applying the chain rule twice. The first thing you noticed is that u should be sine of 3x to the power of 2, and the outer function is e to the u. We apply the chain rule once. We get the derivative of fu, which is e to the u, and then the derivative of the inner function, which I'm just going to write like this, because now I notice that in order to find the derivative of the inner function, I will have to use the chain rule again. So let's now focus on d dx of sine of 3x to the power of 2. The inner function here is 3x to the power of 2. I'm going to call it w because I already were using the variable u. And the big function, the outer function, is sine of w. So now I'm going to replace d dx sine of 3x to the power of 2 by the derivative of the outer function, which is cosine w, times 3x to the power of 2, differentiate, and you get 6x. The only thing left to do now is to express u and w as functions of x. You see that u is sine of 3x to the power of 2, and you can see immediately that w is 3x to the power of 2. And we get that. We are going to do the same in a different way. I'm going to do it directly using the chain rule with three links. That's why it's called the chain rule, because you can have as many links as you want. The number of links in the chain here is 3, because it is a function that's made of a composition of 3 different functions. We will start now from outside in to recognize the functions. It is e to the power, so it's e to the u. And then u has to be sine of 3x to the power of 2. But we want to get 3 simple functions. The links has to be simple functions. That's why I will take u to be just sine of something, of w. And what is w? 3x to the power of 2. Now I'm going to apply the chain rule with 3 links. Let's see. The first function is a function of u, so I can only differentiate this with respect to the u. And I get df du. But the u function is only a function of w, so I can only differentiate this with respect to w, and I get du dw. And then I see that the w is a function of x, so I get dw dx. It's a Leibniz notation. You can really cancel the du and the dw, and you see that indeed you will get df dx. So now the only thing that left to do is to find df du, which is just e to the u, du dw, it's cosine w, and dw dx is 6 times x. And we get that. Now I have to go and express u and w as functions of x. I have to do it now in 2 steps. The only thing that I see is that u is sine of w. Now when I have a function that has w's and x, I can go and change w to be 3x to the power of 2. And I get that. Here is an example of the chain rule combined with the quotient rule. The u is the quotient x to the 4 plus 3 over cosine x, and the outer function is square root of u. I would like to recall for 1 second what is the derivative of square root of x, because here we have to find the derivative of square root of u. It's better to do this on the side. Now I'm differentiating the outer function and I get 1 over 2 square root of u. And then I'm using the quotient rule for the second one. The only thing left to do is to replace u by x to the 4 plus 3 over cosine x. I get that, and you just copy this one. And this is the answer. Example. Differentiate the function e to the power of 4x cubed sine of cosine x. In this case, we have to figure out alone, because there is no dot, that this is a product of two functions. And we have to use the product. Again, we will just do the setup because it's too much to apply two big rules like the product and the chain, and also there are two different chain rules here. As usual, we differentiate the first function times the second, plus differentiate the second times the first. Now I should focus on applying the chain rule to each of those two composite functions. You start with this. Using the chain rule, obviously, u is 4x cubed, and the big function is e to the u. And I get that the derivative of this is e to the u times 12x to the power of 2, which is also e to the power of 4x cubed times 12x to the power of 2. Now I'm going to focus on this one. I will apply the chain rule. U is cosine x, and the outer function is sine of u. And I get, this is cosine u because it's the derivative of the outer function, sine of u, times the derivative of the inner function, and I get negative sine x. Now I'm going to express the u as a function of x, and I get cosine of cosine x times negative sine x. Please be careful, this is cosine of cosine x. Okay, it's not cosine times cosine x, but it means that the angle here is cosine x. Let's put everything together, and we get this. Now we can simplify a little bit. Every time when we have a differentiation with e to the something and we use product rule, more likely we can distribute the e to the power. So here I can definitely do that. And I get that, but now again you cannot combine none of the sine and the cosine here, so this is the answer.